Hi everyone, this is the Winter Precipitation Types module for ForecastBuilder. I'm Ted Ryan, the Science and Operations Officer at WFO Fort Worth, Texas. This module is a bit lengthy, and you're highly encouraged to run through the winter practice case job sheet at the end. At a minimum, you should have viewed the warm season module and feel comfortable with that functionality before beginning this module. In other words, don't just watch all these videos at once if you have not worked with the warm season precip types functionality before. Winter weather in ForecastBuilder is more complicated than warm season weather, but a little investment in learning how to work with the new tools will yield you with some really powerful methods to get grids to align with the winter forecasts that you will need to communicate. In this module, we'll first talk about NBM 4.0 versus NBM 4.1 probability of weather type grids, or POT grids for short, and how and when we'll edit these grids in the Analyze Adjust step. We'll go over the precipitation type step, its GUI, and options when it's in winter mode. This means we'll discuss initializing winter weather types and the new options to control those. We'll spend time talking about consistency checks, specifically how to handle temperature and weather type inconsistencies, and some examples of those. Finally, we'll touch on some optional configurations along the way for sites that use snow level grids and the NBM temperature probability data. Let's get started. The precipitation type forecasts from the NBM are called probability of weather type grids, or POT grids. There's one for each type: POT rain, POT snow, POT freezing rain, and POT sleet. In NBM 4.0 and in previous versions of the NBM, these grids were conditional probabilities, meaning that if it were to precipitate, then the chance of that precipitation being that precip type is given by the value of that grid. So for instance, a conditional probability of snow of 50% and a conditional probability of rain of 50% means that if it were to precipitate, in other words, if we had a pop, then the precipitation would be a 50-50 rain-snow mix. In NBM 4.1, these conditional POT grids are going away. They'll now actually be the actual probabilities of experiencing precipitation of that type. Note that this doesn't necessarily mean getting measurable precipitation of that type. It just means that the model is directly outputting that precipitation type. So rather than using an algorithm to determine precip type in a model that may or may not be precipitating, which is prone to a lot of problems, using direct model output means significant improvements in probability of weather type accuracy and performance have been seen. Since the NBM upgrade is tentatively scheduled for January 2023 in the middle of winter, ForecastBuilder will now convert all NBM 4.0 POT grids to actual probabilities in the GFE. Thus, you will interact with NBM POT grids as if it were NBM version 4.1 right now inside ForecastBuilder. This means we won't have to learn or adjust to a new method in the middle of winter. When you populate these grids in the Populate step and view or interact with them in the Analyze Adjust step, it means that you can easily scan for periods when the NBM is forecasting certain types of precipitation. Here's what these grids will look like after populating, and note that the long POT grids are a sign that a precip type is not being forecast by the NBM. They're all zero, so you get just one giant grid with a zero value. In this forecast example here, you can see that POT rain is broken up, meaning that the values of POT rain are changing at each time step. When viewing one of the NBM POT grids, you'll notice a couple things. First, they'll generally be near the values of the NBM POPs. And from this screenshot, you'll see that these kinds of grids are splotchy and have some artifacts when you're reviewing them in 2.5 kilometer resolution. Those nice and tidy squares are influences from the coarser ECMWF data, while sharp splotchy gradients with values of 20% or more next to zero, like these, are CAMs precipitating, but the global ensembles are drier or aren't forecasting that precipitation type. This is a screenshot of POT sleet. But I think that this can be useful as a forecast aid too, because in a way, just scanning these POT grids and knowing what the squares and splotches mean, you can glean a lot about what model set is forecasting what precipitation type. In this case, I would definitely have a close look at CAMs to see why they're forecasting sleet when the other global models aren't. The bottom line, though, is not to worry too much about these artifacts, but do generally concern yourself with where values are 15% or higher. Initialization of weather types in the upcoming precip type step starts at 15%. Also, know that the ratio of the POT grids values will be used to split QPF up to create sleet, snow, and freezing rain accumulation in the precip accumulation step. What this means is that these POT grids will all be normalized, and if half of the POT value is sleet and the other half is snow, then the QPF sent for sleet and snow accumulation will be split in half. If you're worried about how noisy this data looks, also don't be. These are 1-hour grids, and testing shows that the accumulation over 6-hour chunks all evens out. A key point about pot grids in the Analyze Adjust step: only make edits to these grids to make large-scale meteorological changes. For instance, if a forecaster believes there would be a quicker transition from sleet to snow in this area, or maybe is currently getting ground truth reports saying that it is actually occurring, then they may update the grid here to lower those pot sleet values. After the grids are normalized, it would send more of the QPF to snow accumulation. Other larger scale changes that you may make may be shifting the band of snow or sleet in time and space based on short-term forecast data. You may wonder about these rogue-looking pixels out here that don't seem to fall in line with the main forecast idea. You could edit those now, but actually don't worry about those just yet. The tools in the upcoming precip type step can clean these up much easier. So how would a forecaster make large-scale changes? Use standard GFE tools to adjust the pot grids. These might be using edit areas, pencil tools, or limit values tools. Since I'm usually only editing for this in the short term when the NBM pot data is hourly, I would edit data at select hours and then interpolate those grids. Remember, the idea here is to make large-scale, meaningful changes, and most of the time, this kind of editing is not needed at all. The Analyze Adjust step is just part of the precipitation type forecast process. At the precip type step, we will have another opportunity to make changes, and this is where we can do things like fine-tuning of specific grid points and easier brute force removal or additions of precip types. Since this comes up a lot, the surefire way to remove freezing rain from your forecast is to do this in the upcoming precip type step. That's because pot rain and pot freezing rain probabilities are combined into one behind the scenes and then are split up into rain and freezing rain based on your forecast temperature grids. Thus, you could set pot freezing rain to 0 in the Analyze Adjust step, but any values in pot rain occurring when your temperature is below freezing mean that freezing rain will come back in the forecast in the freezing rain grid. Some additional notes: pot grids shouldn't be totally deleted, but assigned a value of 0 instead. This is to prevent interpolation of pot grids after this step concludes, which can result in some weird looking forecasts. If you add pops to an areas of the grid where the NBM had no precip type defined, or all the pot grids were 0, at the end of this step there will be an automated algorithm to guess the best precipitation type for those grid points. This all occurs behind the scenes, and it may not even be something you notice. WRAP HRRR pot grids will be available later this fall as another population source for pot grids, especially for short-term updates where you may need to toss out the slow updating NBM forecasts and go with something that's handling the short-term trends better. Here's a quick review of the precip type step. Again, remember the purpose of this step is to provide forecaster control of the precipitation types. If you're happy with the NBM forecast, then there's really nothing to do in this step other than initializing your weather types. But obviously, with winter weather, you'll have potentially up to 6 weather type grids that could be created, which is a lot more than warm season, of course. Remember, since your final weather grid is created from all of these grids, your pop at each time will have to have the same value in at least one of the corresponding weather type grids. Here's a review of what the GUI looks like in the warm season. The steps in the winter months are still the same. 1, we're going to hit init weather types. 2, we're going to make edits if necessary. 3, we're going to fix consistency issues if necessary. And then optionally, we'll check weather preview before hitting save continue. However, when temperatures are less than 40 degrees in your forecast period, you will see many more options show up in the GUI for potential winter weather functionality. This can be overwhelming at first, but we'll go over all of these in detail in the next few slides. But here's what's new. There are more weather types to potentially initialize. Snow, freezing rain, sleet, and freezing drizzle all show up here. On the right side, there's a snow TW slider bar. There's a forced snow option. And if you're a mountain snow level site, then there's an option to use snow level. This will be hidden at non-snow level sites, of course. Finally, some offices will have NBM temperature probabilities turned on, and if so, there's an option in the lower right fix tools to toggle this on and off. The defaults are to initialize all weather types. If the NBM isn't forecasting any winter precipitation in your area, essentially nothing will happen. So leave them all selected, it's okay. Unselect a default type if you know the NBM is forecasting a precipitation type that you don't want in your forecast at all. This is a hard override, and it can sometimes create consistency issues we'll need to fix later. Drizzle and freezing drizzle are treated as one weather type in the initialization and then split based on forecast temperature grids. In other words, these aren't addressed separately like rain and freezing rain are. So what kind of weather situation would you omit a precip type? In the extended, when uncertainty is high and the NBM pot grids are forecasting rain, snow, sleet, and freezing rain, but you don't want to mention all of them and would rather just say something like a chance of rain and snow, you might turn off freezing rain and sleet. Let's go over the length of the weather grids. This isn't necessary for you to know, but it will remove some of the mystery of why you'll have some weather type grids of 1 hour and other types of 3 or 6 hours or 12 hours long. Generally, these are set by the length of the pop grid, but are combined into 12-hour chunks if and when they are the same. During winter weather, weather types are also controlled by surface temperatures when they cause a change in precip type. However, ForecastBuilder doesn't use hourly temperature grids through the entire 7-day forecast to show this changeover. This temperature temporal resolution is 1 hour for the first 24 hours, 3 hours through 84 hours, and 6 hours thereafter. So if you're looking at point and click or other graphics for IDSS, you'll get specific hours of precipitation changeovers in the short term. You'll get less specificity in the extended periods. In the case of a switch from rain to freezing rain occurring in the extended forecast, both the weather types for rain and freezing rain will both be forecasts for the same grid point if the hourly temperature during that window is above and below freezing. This will result in a point and click forecast saying something like rain and freezing rain in the evening. Here's an example of the varying grid lengths you'll get with a forecast of min and max temperatures alternating between freezing, with pops in the forecast. Notice the weather types generally match the pop length in the short term because those hourly pops are different at each time step. Thereafter, from 6Z to 18Z, you'll see that pops are 3 hourly, but the weather type grids are still hourly at times. That's because through the first 24 hours of the forecast, or until about 18Z tomorrow, the hourly temperature is warming above freezing, so you'll get hourly resolution of the change over from rain to freezing rain across your CWA. After 18Z tomorrow, it then being more than 24 hours in the future, the temperature grid now is only as specific as a 3-hour window for that temperature change. So your grids will now be 3 hours in length. At this point, if we were to look at these weather type grids, you would see rain and freezing rain in the forecast for the same points, signaling that during that 3-hour period, the temperature will both be above and below freezing. So both weather type forecasts are valid. Finally, you'll see that the weather type for rain, or WXR, is combined to a 6-hour grid tomorrow night and 12 hours after that, only because the smaller resolution weather type grids for rain were identical and it could be combined into a single grid. Again, this combining of identical grids means that there will be fewer grids for you to scan. So let's talk about a more difficult winter weather situation with perhaps all 4 precip types coming into play. In general, the weather type value will match your pop value anywhere where the pot values are more than 15%. The initializations and complex, messy winter precipitation events will do some logic to assign pop values to only the precipitation types that are dominant, and it'll demote other precipitation types to a slight chance or a secondary precip type if they don't make up a significant part of the probability spectrum. If one precipitation type has more than double the probability of the next precipitation type, then the lesser type will be assigned a flat value of 15% in your weather type grids. So, for example, pot snow has a value of 60%, but pot freezing rain has a value of 25%, then pot freezing rain will get demoted to 15%. You'll see this demotion on weather type grids as an area of 15% or a purple ribbon around these types depending on your color scheme. The advantage to doing this method is twofold. We'll get simple wording for the weather grid. It'll just say a slight chance of freezing rain instead of chance or likely or any other possible combinations that could come up. The other advantage is that you can look at one weather type grid, like the freezing rain grid here, and know that freezing rain isn't the dominant precipitation type that's forecast in this area. There's one or more precipitation types that are more likely. So as a forecaster and grid editor, just by looking at this freezing rain grid, you will know that you can remove freezing rain from the forecast here if you don't want it, without creating any consistency issues later. So let's talk about another advanced situation, a really messy winter weather event with lots of model uncertainty. In this situation, an upper low is forecast to move over the area with a change in precipitation from rain to freezing rain to snow. Temperatures are very near the freezing mark, and to complicate things, a dry slot on the south side is resulting in lower pops down there. This kind of situation, when models disagree on the speed of upper-level features, can lead to probability smearing. Without the demotion of precipitation types, it would be really difficult to see the outlier probabilities in the GFE across time and space. In this example, a forecaster can see the 15% probability areas and know that there's inherent uncertainty in the NBM forecast, but only with a minority of the model members. At point A, slower model solutions are holding on to freezing rain and rain longer, while most of the probability is suggesting it should be snow. At point B, faster model solutions are showing a change to snow, but the higher probability is for it to be rain at this time. For the purpose of a coherent forecast message, it makes sense that the progression will be from rain to freezing rain to snow. And at this time range, the forecaster may now be confident enough to message that transition. In that case, they can draw edit areas to remove the 15% area in the rain, freezing rain area on the west side and the 15% snow area on the east side. They know that another precipitation type at that time and space is being forecast, so there's no issues with consistency in making this type of change. Moving on to a couple of the options that are available when initializing snow on the right side. The snow TW slider bar can be set to a threshold that the snow becomes rain instead. The default is usually pretty good, but it can be useful to nudge snow in or out of locations or to make forecaster adjustments based on the current forecast trends. This uses wet bulb temperature grids, which are loaded in the grid manager on this step for you to view. Wet bulb temperatures come from both your temperature and dew point forecasts and the topographic grids. Forced snow is a way to initialize snow using wet bulb temperature only, even if the pot snow grids from the NBM don't have snow in the forecast at that time. What are the meteorological situations to use forced snow? It's helpful in situations where surface wet bulb temperatures are the driving reason for rain versus snow, regardless of what the NBM is forecasting. Another common situation is at the end of a winter weather event, after the NBM starts to dry out and pot grids get sporadic freezing rain types or no weather types due to ice nuclei issues in the model. This very noisy pot snow grid is actually inconsequential in the NBM forecast because pops are below 10%. But if the forecast needs to increase pops because the moisture is hanging around longer, then suddenly there's a splotchy snow forecast that is a problem. One could edit the pot snow grid and the analyze adjust step, but that's probably the slower method. Just check the forced snow checkbox and you're one click away from creating a continuous, reasonable weather type grid for snow. Don't forget, you may wish to use the edit area and time range options to limit this type of weather creation. If you're a mountain site that is beginning to explore the NBM pot method, then this use snow level option will also be available. What it's asking is if you want to use your snow level grids to guide the creation of rain and freezing rain and snow and sleet. By default, it is selected and the weather type forecast will be created so that it's consistent with your snow level forecast. Unselecting this will use just your pot grids for initialization, and therefore you could have snow below or rain above your forecast snow level height. If you were to also unselect this box in the integrity step, that is a way to get a pure NBM forecast for your weather type grids. We're just now starting to explore the NBM and snow level concepts, and after NBM 4.1 is released, we will look at merging these methods for winter 23-24. On to consistency checks. This slide is a review from the warm season module. Consistency between weather type and your POP are still a critical component. POP and weather type grids need to match at every time range, and forecasters could inadvertently create a mismatch between the two. In winter weather, weather types also need to match other forecast variables like temperature and or snow level. To review, hopefully you remember the information on what to do with the POP and weather type inconsistencies from the warm season module. We won't cover that again here, other than to say that these inconsistencies do occur in the winter season as well. POP and weather type inconsistencies will always be addressed before a check on temperature and weather type inconsistencies. Winter weather type consistency can be summed up in these three situations. Snow, sleet, and freezing rain can occur at unrealistically warm temperatures or warm wet bulb temperatures. You can't forecast snow at 55 degrees. Likewise, rain can't occur if you don't have above freezing temperatures possible. And for mountain sites, consistency between rain and snow line and snow level is also usually desired. Essentially, the issue is that you may forecast warm temperatures in the analyze adjust step at a certain grid point, but in the precip type step, you may also forecast something like snow. Of course, this is probably an inadvertent oversight on your part, but it's still inconsistent. You can't forecast both, so you'll need to tell ForecastBuilder which one has priority. Like the pop and weather type inconsistencies, you'll have a button pair to pick from when there's an inconsistency. Either you can fix or force your temperature grid to match your weather type, or fix or force your weather type to your temperature. Some common inconsistencies that show up in the real world are that the forecaster wants to remove freezing rain and or sleet in the forecast, so they don't initialize those types. But that was the only precip type that the NBM was forecasting at those grid points. Another situation that comes up a lot is the NBM is forecasting snow, and the forecaster also wants to forecast snow, but the forecaster didn't notice that surface temperatures were above the snow temperature threshold. This commonly happens because of bias correction being applied to temperature from a series of warm, sunny days, but it is not appropriate for a snowy day forecast. As with pop and weather type consistency issues, when they occur, you'll get a red status message with more information. The offending grids will be colored red in the grid manager, and the button pair to decide which element you want to force to the other one will highlight red. The wording on the buttons may be slightly different if your site has the NBM temperature probabilities option enabled. It will say force instead of fix. If you are a mountain site and using snow level, you'll see your buttons and messages contain snow level or SL on them. Snow level is bundled into the temperature consistency. The ability for ForecastBuilder to automatically adjust temperatures allows for some really powerful uses. The first, it can remove pixelation near temperature thresholds. Secondly, it's easy to fine-tune precipitation types and timing near important locations for IDSS. These tools can save you grid editing time. As a forecaster, we may want to forecast a precipitation type change at a certain time, or we don't want to have grid points that are different because of incorrect temperature bias correction. We usually don't realize these issues even exist until we can see it. Now when we see it on our weather type grids, we don't have to go back to the Analyze Adjust step to edit temperature and then run integrity and then initialize these weather types again. We will actually have ForecastBuilder make those changes for us. Let's go through an example here with the weather type snow grid. Here we are with a slight chance of snow forecast, but there's a noticeable hole over the DFW Metroplex urban area. This is a result of the NBM's temperature bias correction, learning that on sunny days and clear nights, the urban heat island effect is in full force. However, the forecaster knows that if it does snow, the bias correction is not reasonable. Temperatures will be uniform over the area, so a forecast of snow should be as well. Perhaps the forecaster didn't realize they were so close to the temperature threshold in the Analyze Adjust step, so they didn't make a change to the temperatures then. The temperature is forecast to be 40 degrees at 8 p.m., but remember it's the wet bulb temperature that matters, and dew points just weren't low enough with a 40-degree temperature to allow snow to occur. Forecasters have been briefing all day to partners that there is a 20% chance of snow tonight. Surely we want our grid forecast to mention snow everywhere. But the good news here is that we don't have to go back a couple of steps, edit our temp, run integrity, and then recreate our snow grids. We can do this right here and let ForecastBuilder take care of everything for us. To do this, we draw a general edit area of the location we want to fill in the holes in the snow forecast. Then we'll hit the Copy Pop to Selection button on the Edit section of the GUI. This will put the pop into our weather type snow grid for us. When we hit the consistency button, we're going to get red flag. This is because we're now forecasting snow where it's too warm to do so. That's the whole reason the missing pixels were there to begin with. So we'll need to decide which of the two red buttons we want to run, because we want to make sure that our weather type snow grid looks like what we have on the screen. And to change our temperature, we'll force or fix our temperature to match our weather type. This will edit our temperature and dew point grids to lower those grid points to the warmest possible allowable value for snow. You can see here that those temps of 39 and 40 degrees will lower to 38, and it's a natural looking change on this grid. Wet bulb is now at or below 36 degrees. You can do this fix for multiple grids over the entire ForecastBuilder time range that you're doing the forecast for, or if you want to just pick a specified hour, click the time range option in the GUI. It works like any smart tool would. ForecastBuilder will automatically redo any integrity recalculations for other grids like relative humidity, apparent temperature, etc. That will occur once you hit the Save and Continue button to proceed to the next step. Okay, so at this point you may be nervous that ForecastBuilder is going to change your foundation temperature and dew point grids. Don't worry, you'll have the option to revert these changes back to the last saved copy. The status message will tell you to look over them, because here's the reality. The changes made to foundation grids are only meant for minor changes to clean up random grid points or to nudge the forecast. If you're making major changes, they're going to stick out, and it's a sign that you really should be changing your foundation grids. because they're not in agreement with the precipitation forecast you're trying to make. Here's an example where forcing snow to be mentioned with a temperature forecast that's clearly too warm starts to show some unrealistic artifacts. At this point, you would want to revert your temperature forecast and consider redoing the temperature forecast in the Analyze Adjust step if you really wanted to forecast this weather type. Otherwise, you may wish to pick the option to force the weather type to match your temperature, which we'll discuss next. You would be hitting the Force Weather Type to Conform to Temperatures button in a situation where you need to add a weather type if the pot grids from the NBM are noisy or discontinuous, or if a pot grid of that type doesn't exist at all. This allows us to draw some broad edit areas, and then we'll use the temperature grid to cut out the excess weather type where it's too warm or cold for that weather type. This is really useful and powerful if your CWA has terrain, for instance, colder hilltops or mountain peaks, or shorelines where there's warmer water nearby. Here's an example of a messy, discontinuous pot sleet forecast. As a forecaster, I'm looking at this grid 3 days out, and I want to mention rain, sleet, and snow, not this overly precise mess from the NBM. My band of sleet at the transition zone isn't uniform or really even realistic. So I draw a general area where I want to mention sleet. Once again, I hit the button that copies pop to the selection. When my consistencies run, I've got a lot of grid points where it's too warm at the surface to mention sleet at this time. You can view the T or TW inconsistency grid to see where it isn't legal, as I've shown here. At this time, we're going to run the button Fix Weather Type, Keep Temperature. And that will remove pot sleet from where it's too warm, but keep my general band of sleet intact elsewhere. So you can imagine if I had some terrain like hilltops, maybe 2,000 or 3,000 feet higher than the surrounding area, where I know it's going to snow at the top of them, I could use this method to generally draw the region I want to forecast snow and use the Fix Weather Type buttons to remove the excess snow from the valley where it's too warm according to my temperature grids. The same thing could be done on the coastline where it's too warm for snow without having to trace the shoreline with an edit area. Sometimes doing this method of fixing weather type will cut out the only weather type assigned at that grid point. This means you'll get a pop or weather type inconsistency next that you'll have to fix by copying the Copy Me to Weather Type grid to the appropriate precipitation type you want to forecast. The last option that may show up on your GUI, if your site configurations have it allowed, is this Use NBM Temperature Probabilities checkbox. When this is active, it will use the NBM temperature probability data to determine what weather types are legal and at what time. When not selected, hard temperature and wet bulb temperature thresholds will be used to police the grids. For instance, 32 degrees will be the rain and freezing rain dividing line. When the box is selected, you'll find that the consistency issues with temperature are actually very rare because it's legal to forecast rain with the sub-freezing forecast temperature grid. Ideally, as the NWS embraces probabilistic forecasts, we should be forecasting weather types that aren't directly tied to a deterministic temperature and dew point. So if you have this option enabled at your site, when would you turn this checkbox off? In the short term, when you have high confidence in the deterministic temperature forecast and you want other precipitation types removed for streamlined communication, or when we're editing to create weather type grids for certain terrain areas like on the last slide. In those situations, you would not want the probabilistic temperature envelope from the NBM to do the consistency checking. You would want your forecast temperature grids or the deterministic temperature forecast to do that. Finally, I'll give another plug to the weather preview button here. It's super helpful in messy winter weather situations where the final weather grid is too cluttered or messy to read. This grid will color precipitation types. You can use this for IDSS like phone calls to easily step through the grid to see when the exact timing of changeovers occur. The winter mix category has some combination of rain, sleet, and or snow. Ice always has freezing rain mentioned, but may have other types as well. Winter type shading has priority over thunderstorm, which is why you see thunderstop at the winter precip types here. That concludes this video. Again, I strongly encourage you to go through the winter practice case. It's a really messy one, but there's a job sheet that'll give you some hands-on training with using all these consistency checks and performing some of the methods that we've seen here. If you have any questions or feedback for the ForecastBuilder team, those contacts are listed on this slide. Thank you.